Buddy, this is David with IsoHorns, and the prospective customer who was asking about using a dish as a point-to-multipoint sector got back to me. And he said that it was this cluster of subscribers up here that he's currently using the UltraDish 27 to provide service to, and he wants to know if upgrading to the 600 millimeter CPE dish from IsoHorns would provide better service to these subscribers. And then these subscribers down here, because they're closer to his feed, closer to his point of presence, they're using the Ubiquiti Wave 60 gigahertz technology. So that can only go so far. This goes 5 kilometers, so it's outside the range of the Ubiquiti Wave. But he's able to hit these with high-speed, reliable service using the Wave product line. Going back to this, the difference between the IsoHorns and the RF Elements is primarily not about gain. It's primarily about better VSWR and better port isolation. So our VSWR means that the antenna reflects less signal back at the radio than RF Elements. And port isolation means that the vertical and the horizontal polarities are separated so that they don't interfere with each other. So IsoHorns has more than 30 dB of port isolation, and we have less than 1.6 VSWR across the entire range of our frequency range of our antennas, which is the best in the industry. And by comparison, RF Elements doesn't tend to disclose their VSWR nor their port isolation, so you can assume that they're bad. So to figure out whether or not our beam patterns are going to be better, because our 600 millimeter dish is slightly larger than the RF Elements 27 dBi UltraDish. And being slightly larger, it has more gain, it has more aperture, and that also translates into more signal focus, which is what gain is, and a tighter beam width. And so let's see if the IsoHorns tighter beam width might diminish the signal of the stations on the edge of the beam. And so here's the polar radiation plot with the vertical polarity for IsoHorns 600 millimeter dish. And I'm really proud of this. IsoHorns has we have a wide frequency, and so you can select the frequency that best matches the frequency you intend to use. And in this case, I'm going to assume it's a 5 gigahertz system, so I choose 5.5 gigahertz there. And then we can take a screenshot at the negative 6 dB line. So this is the bore site of the antenna, and this right here is negative 3 dB less than the bore site, and this is negative 6 dB less than the bore site of the antenna. And then we can come back here and paste that in, move it over, and we can see that these stations on the edge are within. So right here, say you get a negative 50 dB signal, then this over here on the negative 6 is going to get a negative 56 dB signal. So if the signal right here is strong, then the signal right here at the edge will also be strong. So you should get strong signal for this entire cluster right here. But you got to be careful, because if you move outside and you're right here, then your signal is going to be far diminished. So this is negative 6, negative 12, negative 18, negative 24. So certainly if you end up in one of these nulls, that would be bad. So it's quite likely that the 600 millimeter dish is going to provide better service than the RF Elements dish, not because it's higher gain, but because our other antenna parameters are better, namely our VSWR and our port isolation. Thanks for watching.